Hi everyone, let's continue with lesson 21 on general normal distributions. Let's do some examples. All right, let's say that X is the height of a random American woman. Then X has as its distribution a normal distribution with mean mu being 65 inches and standard deviation sigma being 3.5 inches. Notice these are in the same unit. And there's a source for this. Now, as two key hints for you, these are two key hints regarding the z distribution. This basically says that the probability that z is less than negative 1.43 is this, 0.0764, and the probability that z is less than 2 is this, 0.9772. Two key hints. And by the way, we can verify this with tutorhomework.com. Okay, so what's the left tail probability for negative 1.43? Left tail, negative 1.43, go to probability, and we see 0.0764, which is verified here. For z equals 2, we get 0.9772. So that verifies this value over here. Two key hints. So as you do your work for this example, make sure that you do connect up with these hints. Otherwise, you've made a mistake. Part A, find the probability that X, which is the height of a random American woman. So let's say that we take a random American woman, find the probability that her height is less than 60 inches, or 5 feet. First, we're going to write the corresponding probability expression for Z. I want you to standardize. So notice that on the tutor homework site, it is expecting you to standardize because it's working with z-scores, not x-scores. All right, and we're going to show work by using the formula for z-scores. We take our boundary value here, 60 inches. Sometimes we have two boundary values. In this case, in part A, we only have one, 60 inches. And we need to use this information for this normal distribution to standardize this x-score and turn it into a z-score for a standard normal distribution. All right, so to do that, solution. To find the probability that X, this random woman's height, is less than 60 inches, take the boundary score, x-score, 60 inches, and transform it into a z-score by using the formula for z-scores. So we go from here to z equals negative 1.43, and that's where the hint comes in. How do we get negative 1.43? Well, here's our formula for z-scores. You take the original x-score, subtract off the mean, divide that difference by sigma, the standard dev. Our original x-score was 60. The mean is 65. The standard dev is 3.5. And all of these are in inches. So these are all compatible units. They're all in inches. And in the end, we're basically dividing inches by inches, and the z-score has no unit. So when you work out this fraction, make sure to process the numerator first. It's negative 5. You end up with about negative 1.43 to two decimal places. That's our z-score, about negative 1.43. And as we dictate in the problem, you need to write the corresponding probability expression for z, the standard normal random variable. So from here, the probability that X is less than 60 inches, that's going to be about the probability that Z, the standard normal Z, is less than negative 1.43, which is the z-score for 60 inches. I say about because remember, this was an approximation, negative 1.43. We're rounding off. Although I won't mark off if you put equals. So we want the left tail probability, and from either tutorhomework.com, okay, we can see it's 0.0764. That's the approximate probability to 4 decimal places. Or remember, I gave the hint. That left tail probability, the cumulative probability to the left of negative 1.43, this area, is 0.0764 for the shaded region. Okay, so that is our answer. 0.0764. So there's about a 7.64% chance that this random adult American woman is shorter than 60 inches, or 5 feet. Okay, the next question, the next part, find the probability that this random adult American woman is taller than 60 inches, or 5 feet. And we're going to write the corresponding probability expression for Z, the standard normal. To work out that part, to find the probability that this random adult woman is taller than 60 inches. Well, wait a minute. In part A, we're asking the question, what's the probability that this woman was shorter than 60 inches? We found that was 0.0764. So if we're asking for the probability that the random woman is taller than 60 inches, we want the complement. Remember, it doesn't matter if there's a bar there or not. Well, how do we find the complement? Consider the overall density curve. Okay, the overall density curve has underneath it an area or total probability of 1. We found out in the last example, or in our hint, that the left tail probability was 0.0764. That's the area of this white region over here. But the shaded region is the area that I want. This area is going to be 1 minus the 0.0764. So the probability that x is greater than 60 inches, that's about the probability that z is greater than negative 1.43. That's the probability expression in terms of z. We want the complement. We want 1 minus the probability that z is less than negative 1.43. You don't have to write this part down if you write this. If you go ahead and plug in that the left tail probability is 0.0764. 1 minus 0.0764, that's this probability over here. I'll mark it. 1 minus this is going to be this, which is our answer, about 0.9236. On tutorhomework.com, that'll be the right tail probability, 0.9236. So the probability that a random American adult woman is taller than 60 inches, or 5 feet, is about 92.36%. Okay. Next up, part C. Find the probability that this random adult American woman is between 60 inches and 72 inches. So between 5 feet and 6 feet. The probability that this random adult American woman is between 5 feet tall and 6 feet tall. Again, we're going to write the corresponding probability expression for Z and use the formula for Z-scores when showing work. Well, our first step is to find the Z-scores for both of these two boundary values, this lower value and this upper value. So we take the boundary x-scores, 60 inches and 72 inches, and transform them into Z-scores. So first off, for 60 inches, we use this formula for Z-score, x minus mu all over sigma. Okay, we take the 60 inches for x, subtract off the mean, 65 inches, divide the difference by the standard dev sigma, which was 3.5 inches. The result is negative 1.43. This was the same calculation we did in part A. Now for 72 inches, that's the new piece of information we have to find. For 72 inches, let's find the z-score for that. It's the same z-score formula. This time we plug in 72 inches for the upper left. But since we know these are all in inches, we don't even have to bother with units here. We subtract off 65. That's the mean for the distribution. Divide the difference by the standard dev, 3.5. The result is about 2.00 to 2 decimal places. So the corresponding probability expression for Z looks like this. The probability that X is between 60 inches and 72 inches, between 5 feet and 6 feet, the corresponding probability expression for Z is this. The probability that Z is between negative 1.43, which corresponded to this, and 2.00, which corresponded to that. Remember, for an in-between probability, we subtract probabilities. And again, we got the hints from before. So remember the hints. We have the two hints here. The probability to the left of 2.00 was 0.9772. The probability, the smaller probability, to the left of negative 1.43 was 0.0764. And we have to subtract these two probabilities to get the middle in between probability, or area. So again, we take the 0.9772, take the 0.0764, subtract these two probabilities in order, the greater minus the smaller, and we get our final answer, which is 0.9008, or about 90.08%. So there's about a 90.08% chance that this random adult American woman is between 5 feet and 6 feet tall, or between 60 inches and 72 inches tall. Okay, now before I forget, I'm going to go ahead and show you how to do a calculation using Excel. So let's say we go back to Excel and consider this probability. The probability that X is less than 60 inches, assuming that X has this distribution up here. Mean 65 inches, standard D 3.5 inches, normal. All right, let's go to Excel. So again, we want to find the probability that X is less than 60 inches if X is distributed as a normal with mean 65 inches and standard dev 3.5 inches. Now we could convert to z-scores, and then this will confirm what we got from the website, norm.dist. The z-score of negative 1.43, if we look to the left, that probability is about 0.0764, okay, which is confirmed by the picture over here. Now, the tutorhomework.com website assumes that you know how to standardize and find z-scores. Excel is more liberal. Excel allows you to work directly with the original X distribution. Still, it's good to know how to convert though, folks. It's good to know how to convert. But Excel is more liberal. What is the left tail probability for X equals 60 inches if the mean of the distribution was 65 inches and the standard dev was 3.5 inches? Again, since we have consistent units, we don't have to put units in Excel. We want the cumulative probability. Well, it's the same as what we got from before, about 0.076. I'm a little bit off. Oh, yes, I'm a little bit off because of rounding error. Yeah, because the z-score was about negative 1.43. But if you were a bit more precise, if you used a more precise z-score, then you'd get about 0.0766. We can chalk that up to rounding error when we rounded off the z-score to 2 decimal places. Okay. Now, let's deal with the inverse problem. Given a probability, how do we find the corresponding x-score? Once again, we go through z. All right. So here's the formula that takes us from mu to x. All right. And we get that by taking our formula from x to z. So here's the deal. Back when we were converting from x to z, we use this formula over here, our classic formula for finding z-scores. What I'm doing here is I'm going to derive a formula to take you from z back to x. All right. And we're going to prove this formula over here. So if you remember your algebra, we take this formula here. We're solving for x. What do? We multiply by sigma on both sides. So we get z times sigma equals x minus mu. That bottom now disappears. We're still solving for x. To solve for x, we add mu, the mean, to both sides. I'll put it on the left here. Mu plus z sigma equals x. Turn it around. X equals mu plus z sigma. Which does make intuitive sense, because here's the idea. You're starting at the mean. What happens if you walk mean? Make the tail a little bit bigger. Okay? What happens if you walk z standard deviations away from the mean? So let's say z is positive. If you walk, say, 1 standard deviation away from the mean, then maybe you're here. If you walk 2 standard deviations away, maybe you're here, and so forth. So this formula should make sense. You start at the mean mu, and you walk z standard deviations away. If z is 0, you stay at the mean. If z is negative, you're walking to the left. So here's the formula that takes us from z to x. But now we're going to add on the wrinkle of probability. So before, we went from x to z, and then we went to probabilities. But now we're going to start with probabilities, describing a percentile. We're going to go to z-scores and then get the actual x score, which is really the percentile of the x distribution. So from the probability, we get a percentile for the z distribution, the corresponding percentile for the z distribution, and then the corresponding percentile for the x distribution. Let's do an example. Same distribution as before. We're going to consider, in example 2, x, which is the height of a random American woman. X has as its distribution a normal distribution with mean 65 inches and standard dev 3.5 inches, same as before. Now let's say that to join a particular basketball team, a woman has to be at least at the 85th percentile of heights of American adult women. So let's find the 85th percentile of this distribution of heights of American women, and we're going to round it off to the nearest 10th of an inch. That's 1 decimal place. And we're going to write the corresponding probability statement for x and interpret it. Okay. We're going to use a hint that we used in an earlier lesson, lesson 20, the fact that the 85th percentile for the z distribution was 1.04. If you go to the tutorhomework.com website, I'll clear these out. We want a left tail probability of 0.85. What's the corresponding z-score from right to left? About 1.04 to 2 decimal places. Back here in Excel, norm.inv, we're doing the inverse problem, going from probabilities to z-scores, about 1.04. Okay, so we're going to use this hint. Okay. We first have to transform this x score into we have to transform this z score now into an x score. Before, we were transforming x scores to z scores. Now we're transforming z scores to x scores. And we use that formula I just showed you. You take the mean and you walk z standard deviations away. The mean and the standard dev are in the same unit. Z scores have no unit. We're basically doing inches plus inches. That'll give us inches. All right, although you should write the unit in the final answer. So the mean was 65. The z-score we're looking at is 1.04. That's the 85th percentile for the z distribution. That's from the hint over here. The standard deviation is 3.5. So using a scientific calculator, say, which does the multiplication first before the addition, order of operations, we get 68.6 inches. Don't forget your unit, inches. Remember, z-scores have no units, but x-scores usually do. In this case, it's inches. You could even convert to feet. This would be 5 feet and 8.6 inches. Fairly tall. Remember, we're hiring for a basketball team. Although there is Mr. Bogues. He's fairly short, so you can also be short and be a good basketball player. So here's the picture for the x distribution. What is the x-score, the actual height, that gives us 85% or 0.85 area or probability to the left, the cumulative probability, about 68.6 inches. So an American woman who is 68.6 inches tall, about 5 feet, 8.6 inches tall, that woman will be taller than about 85% of all American adult women. Again, we can phrase it as a probability problem or a proportions problem. The probability that a random American woman is shorter than 68.6 inches is about 0.85 or 85%. framing it as a proportion problem, the proportion of American women who are shorter than 68.6 inches tall is about 0.85. So you can phrase this as either a probability statement or a proportion statement. Okay, so here's the probability statement in terms of X. It's more accessible to stat students. The probability that X, the height of a random adult woman, is less than or shorter than 68.6 inches is about 0.85 or 85%. In plain English, for the layperson who hasn't taken stats yet, about 85% of American women are shorter than 68.6 inches. Or as a probability statement, the probability that a random American woman is shorter than 68.6 inches is about 85% or 0.85. But then you're sneaking in that word probability. Okay, that's lesson 21. Next time, we're going to see another key application of normal distributions, aside from the fact that we see them a lot in practice, the central limit theorem. And it is as important as it sounds. We're going to use this to analyze means or averages. It's a big theorem. It's central. That's next time.